Python input and output is usually pretty straightforward to get started with, and as you might expect, can grow into pretty complex uses as well. We'll do just a very brief overview of a few ways you can do input and output in a Python program. There's, of course, the simple ones that you've probably seen before in terms of printing just a single string, combining strings inside of the print statement and printing them all together, or you may even have seen ones that use commas and where the comma inserts a space between the things that are in there. It is worth noting that Python will get picky about combining things with strings and will often require you to explicitly convert things to strings that you might not have been required to convert to a string in, say, Java. For instance, if I tried to say +3 in this statement here, it would get upset at me that 3 was not a string if I were combining it with the strings that make up hello world. And so I would have to explicitly convert it to a string. So there are some cases in which Python will get a little more picky on I/O than you might have seen in other settings. It does have some structures that are pretty similar to what you might have seen in, say, Java's printf or C or C++ printf type things, string dot format, etc. So there is an operator for strings that is the %sign operator, and it will allow you to do a format string first, similar to what you might do for printf with the percentages. You could do things like %03D to say that this digit needed 3 digits and would pad with zeros, much like you might do in a printf statement in other languages. This is not a special print, though. You'll notice the print itself is regular. What's happening is we're doing an operator that is used for strings to insert things into a format string. What's on the right-hand side of that operator can be a single value if your format string only has a single thing that needs filled in, or can be a tuple of values. If, for instance, I had 3 places that values were going to be inserted in my format string on the left, then I could have a tuple with 3 values on the right-hand side. So this can be one way that you get some of that printf type behavior or string formatting behavior that you might have seen in other languages. There's also an option to use the format function of string objects, but it behaves a little differently than you might expect. For instance, you can use these brackets here for where you're going to be inserting other strings into those portions. So this would build, again, hello world, much like the prints up above. So do be careful that the format function for strings in Python might be a little different than you expect, but between all of these, you can do a lot of the printing cleanly that you might see in other languages. If you want to do command line input, then you've got the built-in input function in Python 3, which will give you whatever the user gave as input in the form of a string. Now, it will always come in as a string. This is not like a Java scanner where you can scan in the next int or the next double or things like that, but it will come in the format of a string, and then you do with it whatever you're going to do. You're able to put a message along with it that gets paired with it as well. So here we printed out the prompt, and then we do the input. Here we've included what the prompt will be as an argument to the input function. Both are valid approaches. You should be careful if you end up working in Python 2, because the input command actually evaluates the input as code. This is horribly insecure and really shouldn't be something that you probably could easily do like this. Probably should take a few more steps and a little more thought so that you don't accidentally do it, which people often do in Python too. So here's an example where I just ask the user to enter a list, and they would have to enter that list as valid Python code with the brackets and then whatever values go inside of it. And if they did that, then I can loop over the data that they've provided there, or I could again execute a full line of Python code, which also means that if they input a Python command that would delete my entire file system, they may well just be allowed to do that, and that would just be accepted. So be very careful about using the input command in Python 2. What you probably want in Python 2 is raw input, which just brings in the input as a string, like the Python 3 input function does. For longer inputs, you can use sys.standardin as if it were a file. It will just be a stream that provides you input. And you similarly can output to sys.standardout or standard error directly, similar to how you might in other languages too. And you can read in from standard in loops or other things like that that might be a little more difficult to do with the input command that's looking for just a single line there. And then you can write to standard out here as this example shows as a stream. So speaking of streams, much like in other languages, you've got your sort of standard streams in Python, and you've got file streams. So here in this example, we assume that there is some file named myfile.txt in the current directory, though of course you could give directory information as well. We can open it as any combination of read, write together, and append. So we're able to say what style of input or output we're doing in relation to that file. So here we open myfile.txt, and then we read a line from it, and then we could do a read to read all of the rest of it. Read in this format will read all of the data in the file up to the end of file. And by the way, the default is that the file was opened with read access, and that's why we're able to do these commands with it. Here, we're opening myfile.txt with write access, and we write the word output to it. Now, this will overwrite the file as it currently exists, and I've also done something bad here in that I didn't close the version that was opened for reading, and this is a common issue in Python programs or in lots of different programs, that we open a file and we don't close it, and then by the end of our program, we've maybe even run out of the available file identifiers that we're able to use. So this is bad structure here, where I didn't close the reading version of the file. I opened a writing version of the file. I'm going to be overwriting things because I didn't choose to append, which may be desired behavior there. So I can write a single string this way, and I can even write things as their own lines. So if I had a list of all of my data points from some simulation I had been doing, I could just put that list into a call to write lines, and it will add new lines after each item in the list as it writes them out. And again, similarly, I didn't close this writing version of the file. I probably should have done that, and we'll see in a moment a solution that Python has for this problem of not closing files that is actually pretty neat and useful. We can loop over files just like we loop over ranges or lists or anything else. So here, for example, I've opened my file.txt, and then I am looping for each line in the file to do something with them, to collect the words that are written on each line. So this is just gathering up all of the individual words that were written inside of that file there. But the main point is that I can loop over the file just like a list or other data structures in Python. So the setup and teardown for a file stream or for any kind of stream can be done automatically in Python using the with keyword. So we say with some file being opened, as f is the name that we're going to use to reference it. So this is similar to before where I said f equals open my file.txt, except Python will now be responsible for setting up the file by opening it and tearing down by closing it. And then we go for each line in the file, print the line, or do whatever we're going to do with that file's information. And when we reach the end of the indented block there, the file is closed. The teardown for that stream is done. And similarly, then below, I say with open my file.txt and write. So for instance, if I wanted to take each line in the original file, remove some characters from it that I didn't want in the file any longer or things like that, and then write it all out to be the same file name, then I could do that, and this would automatically close out the reading version of the file before it starts opening the writing version of the file. Because I've used the with keyword here, we create a block in which that file is open, and once I'm at the end of that block, then the file is closed. And so this can make our code a lot more neat in terms of the setup and teardown things that we don't have to worry about now. And as I was saying, this with keyword can be used with more than just files. You can set up any kind of stream, or you can set up any kind of thing that might require some setup or setup or tear down, a database connection, a network connection. So if you wanted sockets that get opened within a particular block, and then when that block is done executing, they get automatically closed and the teardown for them is done, that's great. You can do that. You define the _enter function and the _exit function, and a few more little pieces to it that you can look up if you're interested in doing that. But once you've set up those two special functions for it, then you're able to use the with keyword for any object of that type, and it will do the enter automatically when you enter that block, and the exit, the teardown, automatically when you reach the end of that block. So there are some structures that can be used in Python to be able to do simple input and output, like your prints and your input statements. But there are also ways that you can extend these. You can use more complicated or a larger variety of different things. One thing that I hope you notice too is that the idea is, again, to provide one interface or to join in with some existing interface. For instance, being able to loop over files uses that existing interface of how we do for loops and doesn't require us to do special extra stuff to detect whether there's more in the file or different things like that. It just uses that existing style and interface for it so that there's one obvious way to do it. And it's the same way you would do stuff like that with a list or a dictionary or whatever else. And then similarly, even this with keyword, which is sort of a special thing in Python, it's set up as a possibility that can become the one obvious way to handle anything that needs setup and tear down, like any type of stream that you might need to use in your program. And so again, the Python philosophy carries through here, that we have simple, readable ways to do a lot of things, and that when those things can be extended, they're extended in a way that fits that one obvious flow of how things are done in terms of input and output in this particular case.